We are going to spend 2 days on this section, talking about expressions and simplifying expressions and exponent rules. Mostly it's just exponent rules. The next 2 days, simplifying expressions is kind of the whole piece of it. But today we're just going to work on really those exponent rules. So let's start out with kind of just a little question here. If I have something like x to the 5th power. So we got, what does x to the 5th power mean? Anybody have any ideas what that means? Yeah, go ahead.
X multiplied by itself 5 times.
Very good. X multiplied by itself 5 times. So that's x times x times x times x times x. Okay. These are made up really in 2 parts. This first piece right here, that part is called the base. And that base is very important. That base is what you're having your exponent to, or your power to. And it's very important that your base is being risen to that exponent. And our exponent in this case, the 5 is our exponent. Okay. That's why it's repeated 5 times. Our base is repeated 5 times, multiplied by itself 5 different times. And it's very important what your base becomes. Your base has to be the part that's being risen to an exponent. So, for example, if I have something like negative x to the 3rd, what's my base in this one? Is it the x or is it the negative and the x? What's being risen to the power? Is the negative being risen to a power? Not in this case. So because it's not being risen to a power, that negative is not part of the base. So if I was going to expand this, what does it mean? This means the negative of x times x times x. Because the x is the only part that is being risen to the 3rd power in this case. Now it differs if I write it like this. I don't mean to put -1. If I put negative x to the 3rd. Now, because that negative is inside the parentheses along with the x, it's part of the base, or it can be considered part of the base. There's 2 ways to consider it. If we're just expanding it, I could rewrite this as negative x times negative x times negative x. One way to rewrite it. That negative needs to be repeated 3 times. Okay? And you got to be able to distinguish the difference between it. If it's inside parentheses and being risen to a power, everything that's inside the parentheses has to be risen to that power. If it's not in parentheses, it's only that base that's being risen to that 3rd power in this case. Okay? So be careful with that. A lot of confusion can happen when we do this. Just to see some other things with exponents, 2 to the 4th. 2 to the 4th would be 2 times 2 times 2 times 2. On your calculators, if you have a calculator, to do this on your calculator, you're going to hit 2 and then look for the caret symbol and then hit 4. Either way, you end up with 60. 2 to the 3rd is 2 times 2 times 2, which is 8. 2 squared is 4, right? What about 2 to the 1st? What's 2 to the 1st equal to? Just 2. Now the one that everybody has trouble with, 2 to the 0. Does anybody remember from Algebra 1 or from, probably didn't do much in geometry. Do you remember what 2 to the, anything to the 0 power is equal to?
2.
No. 1. Anything to the 0 power. Anything to the 0 power is always equal to 1. And that's always going to be the case. Okay. Anything to the 0 power is 1. Now, with these, if you punch this in your calculator, you'd get 1/2. If you punch -2 into the 2 to the -2, you get 1/4. And 2 to the -3 is equal to 1/8. Okay. And if you notice, those, if you look at 2 to the second, 2 to the second is 4. 2 to the -2 is 1/4. So really it's just 1 over 2 to the second. 2 to the third was 8. 2 to the -3 is 1/8. So it's just 1 over 2 to the third. And we'll talk about that concept in just a little bit. Couple questions. Anything to the 0 exponent equals 1. A negative exponent makes a fraction. Anytime you have a negative exponent, you're going to create a fraction with it, as long as that negative exponent is in the numerator. We'll talk about that a little bit more later. Okay? So that's just some basics with exponents. Now let's look at 3 rules. We're going to look at what we call the product rule, the quotient rule, and the power of a power rule. So the first one, product rule. What do we do when we multiply two of the same bases together with exponents? Mathematically, if we have x to the second times x to the fifth, they have the same base of x. This is going to be equivalent to x to the 2 plus 5. So anytime you have two variables, two of the same variables, risen to an exponent, and they're being multiplied together, you add the exponents. So this is equivalent to x to the 7th. And that is your solution. You add the exponents, as long as bases are the same. So if I have something like x to the 4th times y to the 3rd, these two bases are not the same. So since these two bases are not the same, there's nothing we can do with this other than get the multiplication symbol away from them. They have different bases, so we can't add them. Mathematically, if you're looking in a textbook, you would see something like a to the m times a to the n. The bases are the same. The exponents are different. This is going to be equivalent to a to the m plus n. And it's kind of a formal definition of the product rule. If the bases are the same, you're multiplying them together, you add the exponents. With that being said, what if I have x to the 3rd times x to the 5th? Bases are all the same, so it's going to be x. The first one has 3. How many does the second one have? If there's nothing there, what's understood to be right there? A 1. If there's nothing there, there's understood to be a 1 there. So that'd be 3 plus 1 plus 5. Or x to the 9th. Now, obviously, I don't expect you to write this. You can just go from there to there. That's showing work. I mean, you guys know how to add. So just go from there to there. That's the product rule. We good? Happy, happy, joy, joy? Joy, happy, happy? We'll go more into it in a little bit. Next one's the quotient rule. Quotient means to divide. So if you add when you multiply, what do you suppose you do when you divide? Yeah, multiplying and dividing are two different things. Adding and subtracting are two different things. So you're going to subtract. So the quotient rule says that this is going to be equivalent to x to the 7 minus 5, which is equal to x squared. And that's your solution. And we're done. There's nothing left to that piece of it. Let's look at the second one. We got a to the third divided by a to the 7th. So if we look at it from a mathematical standpoint, it'd be a to the m divided by a to the n. That's equivalent to a to the m minus n. So this is going to be a to the 3 minus 7, which is a to the negative 4th. From the first page, we talked about 2 to the negative 3. What was 2 to the negative 3 equal to? 1 over 8, right? We don't like negative exponents. So a to the negative 4th, that's equivalent to 1 over a to the 4th. This is kind of the correct way to put it. We don't like to have negative exponents. We always have to have positive exponents. And the way we make it positive is we just, a non-mathical, we put it where it isn't. If it's in the numerator and it's negative, move it to the denominator. If it's in the, and make it positive. If it's in the denominator, move it to the numerator and make it positive. And you can do that. Basic rule for that is a to the negative 1. That's equivalent to 1 over a to the 1st. These two statements are equivalent to each other. Now, I will also say, no, I don't do it this way. I look at the exponents, and I say, which one's further to the right on the number line? 7 is further to the right on the number line than 3. It's bigger than 3. It's more positive than 3. How much bigger is 7 than 3? 4. Because 7 is bigger, that means it's going to go on the bottom. The difference between 7 and 3 is 4. That's why it's 1 over a to the 4th. I find that easier to do and less writing than doing all of this. But that's just me. We'll come back to more of those here in just a second. Let's get you the last rule. The power of a power rule. So we have a base and an exponent being risen to another power. So it's the power of a power rule. Power of a power rule simply says that everything inside the parentheses needs to be taken to that power. And when you take it to that power, you are going to multiply. So x squared is going to be x squared times 3, which is what our outside power was. Y to the 5th, we also have to take times 3, because that's our power. Power to power, we multiply. You brought me food. That's so nice. Thanks. What we got? Yeah. Hy-Vee Chinese?
Nah, this is.
X to the 6th, y to the 15th. There's your solution. 2 times 3 is 6, 5 times 8, and you're done. So power to power. Power to power, you multiply. Quotient, you divide. Quotient, you subtract. Product, you add. Those are kind of our 3 rules for today. We got the product rule, the power rule, and the quotient rule. Mathematically, the power rule would say a to the m to the n is equal to a to the mn. That's mathematically how you would look at it. So now let's put them into context. Let's take them a little bit to the next step. So start with practicing with the product rule. If I have 5y to the 7th times 3y squared. There's coefficients in this now, numbers. Our coefficients are just numbers. You are going to multiply the coefficients together and add the exponents together with the same base. So you treat the numbers like you normally would if you were multiplying. 5 times 3 is 15. So our answer for this is 15. You add the exponents. Y to the, good job adding 7 and 2, it's 9. You're done. Nothing left to do with it. Okay. Look at number 2. Now we've got 3 ab to the 3rd times 5a squared b to the 6th. Multiply the numbers. 3 times 5 is 15. The a's. Remember, there's understood to be a 1 there. 1 plus 2 is 3. B. 3 plus 6 is 9. There's your solution. And you're done. All right. Any questions with that one? We're rolling? Math isn't that hard. Try that one. Three times 2 times 2, 12. We've got 12. I like to go alphabetical order, so U. How many U's do we have? 4. Understood to be a 1. 1 plus 3 is 4. Ooh, V's. 4 minus 3 minus 3 is negative 2, right? Can't have negative exponents, so what do I do to make it positive? Put it to a fraction, or I can just drop it down to the denominator. That's your solution. And you're done. Okay. We're going to take a couple days on this stuff. It's not something that we're going to do in one day. You're going to have time to look at these again tomorrow. So I got some quotient rule ones. (10m to the 9th) divided by 15m to the 3rd. Subtract the exponents and then reduce the coefficients. I do it the other way. Reduce the coefficients, so reduce the numbers. So we pretend that doesn't exist. And you have 10/15. 10/15 reduces to 2/3. 5 goes into 10 twice. and into 15 three times. Where's the m value bigger, top or bottom? What's bigger, 9 or 3? 9 is bigger. So that tells me the m is going to go on the top. 9 minus 3 is 6. Here's your solution. Okay. Try those two and see how you do. Where's the x bigger, top or bottom? Bottom by how many? 3? Where's the y bigger, top or bottom? By how many? Remember, there's understood to be a 1 there. 2. There's nothing on the top. We have to have something on the top, so we just put a 1 there. And you're done. Second one. Where's a bigger, top or bottom? By how many? 5. Where's the b bigger, top or bottom? By how many? 4. There's your solution. We can divide? Good with the dividing? All right, then let's practice the product rule one. Go over some things with the product rule that everybody forgets, and then we'll call it good for the day. Power to power rule. So we've got 5a to the 7th squared. We talked about it when we were going through it originally. You have to make sure that you raise everything to the outside power. Like I said, that negative, you have to raise that negative to that outside power. We have to raise the coefficient, the number, to that power. So this is going to be 5 squared. We have to take the 5 to the second power. 5 times 5 is 25. A, what do we do with the exponents when we go power to power? Starts with an M. Multiply. So 7 times 2. 7 times 2 is 14. There's your solution. And you're done. Ta-da. Questions with that one? Okay, let's look at number 9. We've got inside parentheses, negative 3x to the third, y to the fourth. So that means that that negative has to go to the fourth power as well. So you could say negative to the fourth. What's a negative times a negative times a negative times a negative? Positive, right? Okay, so we know this is going to be positive. Probably not the way you're going to do it. Probably the easiest way to think about it is as negative 3 to the fourth power. Same thing. 81. X. How many x's do I have? I've got 3 here. What do I do with the 4? Add it or multiply it? Multiply it. 3 times 4. My book is 12. Y. We've got a 1 and a 4. 1 times 4 is, there's your answer. And you're done. Nothing left to do with it. Okay? That's what you're going to work on today. You're going to work on these 3 rules. Product rule, remember you add the exponents. Quotient rule, you subtract the exponents. And power of a power, you multiply the exponents. You're going to have today and tomorrow to work on this. You have an assignment today. It's inside school, will be sitting there already. That's the whole thing is due. You're going to have time to work on that tomorrow at the beginning of class as well if you don't get it done. Then we'll take some time, go over those answers, make sure everybody's good to go. Take a couple more questions, and then we'll give you pretty much like 80% of tomorrow to finish up the worksheet that you'll get tomorrow. So tomorrow essentially becomes a not new learning day, just refreshing what we did this week day. You good?